Okay, we're going to start section 5.1, angles and degree measure. A lot of vocabulary today. We're starting basically the second half of the year. Just going to cover a lot of trig. So angle measure, the measure between two rays, the initial and terminal, that share a common endpoint called the vertex. So as you can see here, we have the initial ray, we have the terminal ray, we have an angle, which we call alpha. We use a lot of Greek letters. We'll be using alpha, beta, theta, gamma, a bunch of different Greek letters to do this. And then the point where they meet, right here, we call the vertex point. So that's what defines an angle measure. Now the standard position of an angle, this is when the initial ray lies on the x-axis and the vertex point lies at the origin. So in both of these examples that we have drawn here, we have the initial ray on the x-axis. Okay, and then we have the terminal ray, which I'll draw in blue. Terminal ray somewhere else. Now, if you are measuring in a counterclockwise fashion, you will be measuring positive angles. If you are measuring in a clockwise fashion, you have negative angles. So you can see in this first, we're going in a counterclockwise way. We're getting positive 120 degrees. Okay, there's also a lot more information here. You can see our quadrants are 1, 2, 3, and 4. And we measure 90, 180, 270, 360. 360 would be one full time around. Now, in the second drawing here, the angle is drawn in a different direction. It's ending at the exact same spot. Okay, notice that the quadrants do not change. So we still have quadrant 1, 2, 3, and 4. Okay, but we're going to go from starting at 0, we're going to go in the opposite direction. So the next angle would be negative 90, negative 180, negative 270, negative 360. So when we're drawing an angle in the clockwise direction, it's going to actually be negative. So this angle that we drew here is negative 240 degrees. Okay, degrees can be broken down into smaller increments called degrees, minutes, and seconds. So here we have an example. Change north latitude 15.735 degrees to degrees, minutes, and seconds. Now there's a couple different ways that we can approach this. The easier way is probably to use technology, but we can do this by hand as well. Let's first approach this with technology. I'm using a TI 8384 graphing calculator. Okay? And we're going to convert 15.735 degrees to degrees, minutes, and seconds. Okay, so 15.735. So we just simply type in the angle that's currently in decimal degrees. Okay, and we're going to hit second button and then the blue apps button. This is the angle menu. You can see number 1 is the degree symbol. 2, that's going to be for minutes when we get to that. 3 represents a radian. 4 is our DMS. Okay, so we're going to go down to number 4 and choose that. So we want to convert this decimal into degrees, minutes, and seconds. We hit enter and we get our answer. 15 degrees, 44 minutes, and 6 seconds. So a single apostrophe, if you want to call it that, would be 44 minutes. A double would be representing seconds. So what exactly does that mean? Well, 1 degree equals 60 minutes, and 1 minute equals 60 seconds. So 44 minutes out of 60 minutes is about 75, 3/4, 0.75. And as you can see, our decimal is 15.735. It's very close to that 0.75. So it's just a way to convert it from decimal to degrees, minutes, and seconds. Degrees, minutes, and seconds affect all of us. Usually in the past, we wouldn't talk about it much because it really didn't affect us. Boats are the big ones that used it, with latitude and longitude, knowing where they're at. But anymore, every person, almost every person, probably has a cell phone that has GPS, Global Positioning System, or maybe in the car, or a portable device, GPS, where it tells you exactly what latitude and what longitude you are at. And you actually have options. The GPS that I have can be decimal, it could be minutes in decimal, or it could be degrees, minutes, and seconds. You have that option to choose. All right, let's go the opposite direction now. We're going to convert DMS to decimal degree. Again, we'll start with technology. Give you a second to copy this down. Okay, so 39 degrees, 5 minutes, 34 seconds. We're going to convert that to decimal degree. Okay, so we're going to type in 39, and we're going to go to that angle menu, second apps, and choose number 1, degrees. We'll type in 5, second apps, number 2, minutes, and then 34. Okay, we're not going to go to second apps. Okay, there is no double slash in second apps. It's actually right here on the calculator. It's alpha, which is the green button, plus. Alpha plus gives us the double slash, which represents seconds. And we just hit enter. It automatically converts it to decimals. So 39.093 degrees. Well, what if you didn't have a calculator? Well, we can take 39 degrees, and we're going to add 5 divided by 60 minutes. And once we divide by 60, now it's a degree. And then we're going to add 34 over, no, it's 3,600. Because to go from degrees to seconds, we have to do the 60 conversion for minutes, and then we have to do the 60 conversion for seconds. 60 times 60 is 3,600. That now turns that into a degree. So if we take the 39 degrees plus 5 divided by 60 plus the 34 divided by 3,600, which I'm just going to type into the calculator. You can do this by hand. It takes a little bit longer without the calculator. We get the same exact decimal, 39.093 degrees. So that's converting from degrees, minutes, and seconds to decimal degrees and the opposite. Okay, another vocabulary word, a quadrantal angle. When the terminal side of an angle lies on an axis. So if your angle that is drawn stops on an axis, we call it a quadrantal angle. I have several examples here. The first being 90 degrees. We have our initial on the x-axis in standard position, and the terminal is ending on the positive y-axis. That's a quadrantal angle of 90. Here we have the initial on the x-axis again in standard position. The terminal ray is on the negative x-axis. In that case, that's negative 180 degrees. And our initial ray again in standard position on the positive x-axis, and the terminal ray is ending on the negative y-axis. In this case, it is positive 270 degrees. So that's just a vocabulary word, quadrantal angles. Any angle that ends on an axis. Again, if we're going too quickly, please just pause the recording, take your time to copy the notes down, and then move on. One rotation is equivalent to 360 degrees. This is a conversion, something that you should know from geometry. One time around is 360 degrees. We're going to use that to convert rotations to degrees, and we could do it the other way. We could convert degrees to rotations. So the example, give the angle measure represented by each rotation. This is actually, again, used. If you've ever seen snowboarders or skiers do jumps, they usually call their jumps by the angle measurement. So if someone spun around a certain amount of times, instead of saying they did a 1.5 spin, they would say what the equivalent of that is. So let's say they spun around 5.5 times. What would they call that? Well, if we simply just take 5.5 times 360. Now we have to be careful here, because clockwise is a direction. Clockwise is in the negative direction, so this is going to multiply by negative 360. So 5.5 times 360, negative, is negative 1980 degrees. So they probably call it a 1980, or reverse 1980. I don't think they say negative. If you were spinning around doing a ski move and you jumped and spun around 5.5 times, they'd call it a 1980 or maybe a negative 1980. Usually it's difficult to spin around that many times, so that's probably why you haven't heard of that one. 1.5 times, 2 times. We did 1.5 real quick. 1.5 times 360. Okay, that's 540. I'm sure you've heard of that. So 3.3 rotations in a counterclockwise fashion. Counterclockwise is going to go in this direction. That's the positive direction. So 3.3 times positive 360. We get 1188. So 1188 degrees. 1188 degrees. If you're going to go the other way, if you're going to convert from from degrees to rotations, instead of multiplying by 360, you would simply just divide by 360. Okay, another vocabulary word, coterminal angles. If alpha is the degree measure of an angle, then all angles measuring alpha plus 360k degrees, where k is an integer, are coterminal with alpha. That's the technical definition. See if we can translate that into English. Coterminal. Coterminal means coinciding terminal rays. So if two angles are coterminal, that means they have coinciding terminal rays, which simply means they end at the same point, the same ray. So to figure this out, we're simply just going to spin around until we get to the same point. And we do that by adding and subtracting 360. So let's take a look at the example. Identify all angles that are coterminal with each angle. Then find one positive and one negative that are coterminal with the angle. This represents all coterminal angles. So since our first angle is 45 degrees, all coterminal angles are represented by 45 degrees plus 360k degrees, where k is an integer. 0, 1, 2, 3, negative, 1, 2, 3. Okay, positive and negative counting numbers. That's integers. If we want to find a positive one, there are infinitely many. We can keep adding 360 forever. We can keep subtracting 360 forever. We just want one of them. So I'm going to simply just take 45 plus 360 one time. And that will give me one positive. 45 plus 360, 405. So 405 degrees would be a positive coterminal. To get a negative, you take 45 degrees minus 360. So 45 minus 360, negative 315. One positive, one negative. Okay, let's talk about 225. All coterminals would be 225 plus 360k degrees. That's all of them. A positive, 225 plus 360. A negative would be 225 minus 360. So 225 plus 360, 225 minus 360. So 585 and negative 135. One positive, one negative. If the angle is much larger or much smaller, you may have to add multiples of 360. You might have to add 360 5 times in a row to get to a positive. Or you may have to subtract 360 7 times in a row to get a negative. Okay? If the angle is much larger, say instead of 225, it was 2025, you'd have to subtract 360 a lot more than just once to get a negative. Now let's continue with the coterminal. If the following angles are in standard position, determine a coterminal angle that is between 0 and 360. So now we're not necessarily looking for any positive. We're looking for a very specific positive angle that is between 0 and 360 degrees. State the quadrant in which the coterminal angle lies after you get that angle. So we'll start with 775. To get to something between 0 and 360, we're going to subtract. So 775 minus 360 equals 415. 415 is not between 0 and 360, so we're going to have to subtract again. We get 55 degrees. Okay, that's the angle. That's coterminal with 775. What quadrant is it in? Well, 55 degrees would be quadrant 1. Okay, 415 would also be a coterminal. That's a positive coterminal, but it is not between 0 and 360, so it's not answering our question. Okay, negative 1297 degrees. We need something between 0 and 360, so negative 1297 plus 360. We're going to start adding 360, and we're going to do that until we get to something between 0 and 360. So negative 937. We'll take negative 937 and add 360 again. Negative 577. Still not there. Negative 217. Still not there. Oh, finally, 143 degrees. Now, all of these results are all coterminal. Okay? Negative 937, okay, negative 577, and negative 217 are all coterminal with the original negative 1297. They're all negative coterminals. Okay? 143 is the first that's between 0 and 360. Where is that located? Negative 143 degrees is in quadrant 2. Okay, again, you've got 90, 180, 270, 360. Okay, so that's going to be somewhere between 90 and 180, quadrant 2. Coterminal angles. The key is add or subtract 360. Coterminal, think 360. Now, next vocabulary, reference angle. The acute angle. Acute, meaning between 0 and 90 degrees. From geometry, we had acute angles and obtuse angles. Okay? Acute, between 0 and 90. Obtuse, between 90 and 180. So we're looking for something between 0 and 90 degrees. So the acute angle formed by the terminal side of the given angle and the x-axis. We always use the x-axis. We never, ever, ever use the y-axis. The distance from the terminal ray to the x-axis is your reference angle. Let's take a look at a couple examples here. Find the measure of the reference angle for each angle. 120 degrees. Okay, let's draw pictures so we understand this. Where is 120 degrees? It's in quadrant 2. Now, the reference angle is the distance from the terminal ray to the closest x-axis. That distance should be less than 90 degrees. Now, that x-axis is 180 degrees. So what is the distance from 180 to 120? Well, I think you can do that in your head, but if you can't, it's 180 minus 120, or 60 degrees. 60 degrees is the reference angle for 120 degrees. Reference angle is a very important angle. We use it all the time when we are solving triangles, okay, or solving any problem using sine, cosine, tangent, using trig functions. Okay, the reference angle is what we will utilize. So you must know how to get that. So if you have an angle that's in quadrant 2, you're basically going to take 180 minus that angle. Let's take a look at part B here. Negative 135 degrees. Okay, this is negative this time. So negative 135 is going to be in quadrant 3. The distance from the terminal ray to the closest x-axis is the reference angle. So to find that distance, we're going to subtract the two numbers. So negative 180. So let's go the other way. Negative 135 minus minus, or plus 180, gives you 45 degrees. Okay? Both of these reference angles must be positive. So let's say you subtract in the wrong direction. Let's say you take negative 180 minus minus, or plus 135 degrees, and you get negative 45 degrees. A distance is not allowed to be negative. It's a distance. It's always positive. So if you do end up getting a negative, simply just take the absolute value and make it positive. The reference angle is a positive angle between 0 and 90 degrees. All right, that's it for the lesson. That might be tonight's homework. It might not be, depending on how much we got covered in class. Please refer to my homework calendar to see what the actual homework is. But this is probably going to be close to what that is. I believe we broke it up into 2 days, so this homework's probably going to be split up. Check out the homework calendar.